Hey there, welcome back. This is part 2 of our service discovery series. In the last one we set up console, and now we're going to use it for something interesting rather than just looking at the GUI. We're going to start by adding a package to our API service, and this package is going to be something called condenser.net. Connects up to console for you. It takes care of all the API calls and various other things. It's a heavily opinionated framework, but it also has some nice integrations with ASPNETCORE, or running, whether you're running on full desktop or you're running on the NetCore app framework. So let's search for condenser, and we're looking for condenser.net.client. So this means it is a client of the console service. So we'll go ahead and add this to our core, and then we will install. So the first thing we need to do is have our services actually register with the service discovery platform so that we can find them. To do this, we will add a using of condenser.net.client. And then we will come down to our configuration methods down here. And the first thing we're going to do is add console services. So services.add console services. Currently, the condenser.net package only works with console. However, in the future we're hoping to expand that out to some other service discovery platforms or providers. Next thing, we're going to add a service manager to our injection for the configure. So the iService manager, and on the service manager we'll call .registerService async. In this version of Kestrel or hosting that we're running, these methods currently aren't async, so this will just finish when it finishes. In 2.0, there are rumors, and we might take a look at it later, of actually having an async configure method. Let's start up our service now, and let's take a look and see what's happened. Now you notice we haven't really done a lot. This is because if you leave it the defaults, it'll look for localhost port 8500, which is the default for console. The other thing it'll do is it'll pull out the URL that you're listening to, or URLs, find the first one and the first public IP address that you are listening to also from Kestrel, and it will assume that that is the URL that you can hit the service on. It'll also pull out the port information. So you can see here we've got 10.0.75.1 and 8889. So that is the address of our server, and obviously the port that we're running Kestrel on currently. So all that's done for us out of the box. You can configure the service name yourself. It will actually take the name of the entry point DLL, and it will strip off things like host and service off the end. Now, next thing we're going to do is we're going to regen our Swagger doc, but we're going to use the -internal constructors flag. The reason for this is we want to hide the default built constructors, because we no longer want to supply a URI directly. Instead, we want to get it out of our service discovery platform. So now we've done that, you can see that we've got a build error because the Swagger document storage no longer has a public constructor that we can use. So we're going to go ahead and add the condenser.net client to our API client, add that package there as well. And there's another class that we're going to use, which is called the iService registry. Now the iService registry will look up services for us automatically from console. Once you first look up a service, it will then keep in contact with console on a callback mechanism using HTTP long polling behind the scenes, and it will be notified by console every time there's a change in services, e.g. there's a new service available, or an existing instance of that service collapses or goes away, ends up with bad health or whatever. And we will keep an internal list inside the condenser.net client library for you. The thing about that means that if we lose contact with console, we will still have addresses for the services. And every time you make a call to those services, you're not actually going to console, looking up the service and coming back. Instead, it's just literally a super fast dictionary lookup. You can switch the mechanism by which you select the service out of that list. You can inject your own. We can take a look at that maybe later on as well. It's simply an iRouting class. However, the default one is randomization. Now you might ask why we don't do round robining, and the reason is because every client would be doing round robining, and that wouldn't actually achieve the result you think of. Instead, very possibly, especially if the clients are hitting at about the same speed and come up at the same time, they'll all be hitting the same service one after the other, and random will give us that distribution that we want by law of large numbers. However, if you want to, as I said, change that, we can definitely look at showing you how to do that later on. We're going to make an API client class. Now the reason we're doing this, and we're not giving it a specific name, is that we might actually be able to reuse this throughout our project later on. We'll take a look at that. We might even make a NuGet template, so we can do a .NET new for these. And what we will do is, from that registry, we'll call .getHTTP handler, and we'll inject that into the base class. Now what this is it provides an HTTP handler that takes a URI that actually just is a service name, and it will replace that every time you call for an actual IP address of an available instance of that service. So to try and make this generic once again, instead of hard coding a string, we'll just do HTTP, $sign there, and we will take the full name of this class. So now we'll go back over here and change this to the API client. First of all, we're going to have to make an instance of the service registry. Now, once again, it'll just automatically use the defaults of localhost port 8500. You can inject a configuration object in there if you want to change that. And normally, you wouldn't actually create this yourself. That add console services will put it on your container for you automatically, and you can just inject it. So you could therefore then just put an register the API client with the container as well, and this will get injected for you. However, in our sample app, we haven't got a container yet. We could put one in, I guess, just to show the point, but for now we won't. And we start this up. We're on port 8889. We can see here we've got an instance of the service, and we'll run, and it's going to fail. And the reason is it's looking for local host still. And that's because on the generated class from the auto rest, what we actually need to change is the base URI, not the URI of the HTTP handler. The HTTP client. So let's try again. And the result is failure again. We've got the class name in there. So we need to get rid of that. So what we want is the namespace. And quick try again. And this time, hopefully, fingers crossed. No. Once again, we've got API on the end. Okay, as I said, it would have been easier if we just hard-coded a string, but we've gone down this path now, and hopefully we can make this generic. So what we'll do is we'll make a variable called ns, and we will strip off anything past the last dot. Now, I'm not so worried about string manipulation, etc. This is not a hot path. The idea is you make a single instance of this API client, and you keep it around in your container, just like you would with an HTTP client, and you keep calling it over and over again. One advantage of using service discovery here is we're actually going to avoid the DNS lookup problem and caching problem that people have with the HTTP client, because there is no DNS lookup. And in fact, instead, that HTTP handler internally is going to be keeping that list of services and rotating us around the various instances automatically. So this time we'll just throw ns in there. Put a breakpoint on here in case we have problems still. Of course, we're not going to. And run. And look at that. We can hit our service. So now our test app has 0 configuration required, and we can move our service address around. So what we're going to do is go ahead and kill our current containers, kill our current console container, because basically if we start up a service on another port, the old service will be there, and we're going to go through shortly about how to fix that problem. But for now, we just don't want that failure. So now we can see we've got no services. Let's go and change the port that our service runs on. Just to prove the point, let's go up to 9000, start it up, and start up our client app. Once again, we've changed nothing in our client app, and there we go. We can connect now with 0 configuration in our client app. That's it. So that's our very basic service discovery. In the next ones, we'll go through how to actually manage our services within the service discovery, including health checking and a few other things. Thanks for watching. We'll see you next time.